Okay, this is section 6.4 and 6.5. There is only one topic from section 6.4, but it's a doozy. I don't think it's as bad as linear programming, but it's not a great topic. And then we have two topics from 6.5. Those ones are, I think, pretty easy as soon as you know the procedure for it, okay? So I know how to work a smart board. Okay, so in the world of matrices, there's something called an identity matrix. An identity matrix has ones on the diagonal and zeros everywhere else. And the reason that it's called an identity matrix is that if you multiply another matrix by the identity matrix, you get that matrix back. So in the world of matrices, it's like multiplying by 1. Right? So like with numbers, if you times by 1, the answer is itself, the thing you started with. In matrices, if you times by an identity matrix, you get your matrix as the answer. The reason that you need to know that is because we're going to use identity matrices to help us. We're going to be finding inverses of matrices. So it's called identity if you times something by that identity thing and get itself back. It's called an inverse if you multiply something by its inverse and you get 1. So for example, in the world of numbers, if you start with a 3 and you times by 1/3, you get 1. So 1/3 is the multiplicative inverse of 3. What our topic is to find the inverse of a matrice. So like we want to be able to figure out what do I times this by to get an identity matrix. So we're going to do a couple things first just to kind of get used to the idea, and then we'll practice finding an inverse. So A and B, it says determine whether A and B are inverses. Well, they're inverses if we times them together and we get an identity matrix. So if we practice timesing those together, in our first element, it's 3 times 5 and 2 times -7, so that is 1. In our second spot, we get a -6 plus +6, so we get 0. On the second row, we have 7 times 5 and 5 times -7, so that adds up to 0. And in our last spot, we have 7 times -2 and 5 times 3. So that's a -14 and a +15, which is 1. So if you times them together and you get an identity matrix, that means they are inverses of each other, in the same way that 3 and 1/3 are inverses in the number system. So I am going to show you how to find an inverse with a 2x2 matrix first, because that is a little easier. And then what your topic is to find an inverse of a 3x3 matrix. So doing it with a 2x2 matrix is kind of like a baby step towards our goal. You won't have to do any 2x2 matrices in your topics, but it's kind of easier to see what's happening with the 2x2. So what you do is you augment your matrix with an identity matrix. So that means we're going to make a little bit bigger matrix. We're going to have the thing that we want to find the inverse of, but we're also going to put an identity matrix of the same size next to it. So we've created this matrix that's sort of twice as long as the original matrix. And to find the inverse, what you do is you do row operations until you've migrated the identity matrix here, and what's left here is going to be the inverse. So the first thing we might do is divide by 3 so that we have a 1 here. So our goal to finish is to have 1, 0, 0, 1, something, 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 something. And we don't know what those somethings are yet. But this is the answer. when we finish. Now, I like to do my best to avoid fractions at all cost when I am doing this, because fractions start to get ugly. I can't do them as fast in my head as I can with whole numbers. So even though I said a second ago, the first thing you might do is divide by 3, personally, I would not do that, because if I divide by 3, I'm now having to deal with 2/3 and 1/3 in my matrix. So instead, I'm going to kind of look at these and think about like 7 and 3, and I need to end up with a 1. If I times by a -2, these will be different by a 1. So what I'm going to actually do is I'm going to switch the rows, which that's an okay matrix operation to do. I'm going to switch the rows so that the 7 is on top, and then go from there. So switch rows. You can switch rows as long as you switch the entire row. Don't switch parts of rows, right? So it's going to be 7, 5, 0, 1. Okay, now I'm going to multiply my bottom row by -2 and add it to row 1. So it's kind of a clever way of getting a 1 and avoiding fractions. So -2 times this row plus this row. Is that okay? So -2 times 3 plus 7 gives me 1. -2 times 2 plus 5 also gives me 1. -2 times 1, adding to 0. -2 times 0 plus 1. Remember, when you're doing a row operation, you only change one row. So I changed the top row, my bottom row stays the same. I times this by -2 and added it up. Okay, so what do you think we should do now? Once you have a 1 here, goal might be to get a 0 directly below it. So we can multiply the top row by -3 and add it to the bottom row. -3 row 1 plus row 2. And we're only changing row 2. So row 1 stays the same. I'm going to write that. Does that help you see what I'm doing if I write that? It's kind of weird, but I would, if you're doing that on yours, I would definitely do it in a different color so you can tell what you're thinking about. -3, that's our 0. That's -1. This is 7. Am I mathing right? Did we get a 7? And then -3. Oh, this is good. This is really good. This worked out great. So we do want a 1 here for sure, but I wouldn't divide by -1 or change the signs yet, because if we add it up right now, we're going to get our 0 above it, and then we can divide that negative away. So we're just going to add row 2 to row 1. Whoops, plus row 1. And we're going to put that in the row 1 spot. So we're changing row 1, not row 2. So row 2 stays the same. Row 1 becomes 1, 0, 5, -2. And we're almost done, because our goal was to have the identity matrix right here. So we just need to change our signs on that bottom row and we'll have it. So A inverse is 5, -2, and if we're changing our signs, that would be -7 and +3. And that's our inverse. So like I said, your topic is to do this with a 3x3 matrix. So it's a little more intense when it's 3x3. We are going to augment it with an identity matrix, so we're going to be dealing with a lot of numbers. And in fact, I'm just going to, let's see, I'm going to do this. I'm just going to do 1, 0, 0, so I don't have to waste that space on my board. So identity matrix has 1s on the diagonal, 0s everywhere else. Oops. There. Like I said before, for me, I avoid fractions at all costs. And I see that 2 and that 4, and I'm thinking I actually want the 3 on the top. Can you see why having the 3 at the top might be advantageous? Yeah, and we can get zeros from the other 2, I think. So I mean, there's not like one path. You can, do what you think is going to work right, but I can see getting a 1 on the top row if I move the 3 to the top and add the row that has the -2. So I'm going to do that. So so the operation I'm doing is that I'm switching row 3 and row 1. That's all I'm doing right now, is just switching the bottom row and the top row. Middle row stays the same. Okay, so now I'm going to do row 1 and row 3 added together, and that's going to give us a 1 in our first position. Row 3 plus row 1 going to row 1. One, -5, 7, 1, 0, 1. You got to check mine. Don't copy mine. Do it yourself and check mine. I'm adding the top row and the bottom row together and putting it in the top. Oh, geez. Okay, so are you okay if we eliminate the 4 and the -2 all at once, or will that be gross? Okay, it'll save you a little space writing. So I'm gonna use colors to help us see what's happening. So I'm gonna times the top row by -4 and add it to the middle row. And that's gonna go to the middle. Okay, so -4 times the top row plus the middle row is gonna give us the middle row. I'm not going to change my top row at all. So I'm going to write my top row in, but I'm not going to write anything else, just my top row. 1, -5, 7, 1, 0, 1. Okay, so if I do 4 times the top row plus the middle row, that's going to be 0. -4 times the top row plus the middle row. So -4 times 1 plus 4. So this will be -4 times -5, so that's a 20. Minus 13 gives us 7. This is a -28 plus 10. This is a -4 plus 0. This is a 0 plus 1. This is a -4 plus 0, which is not a 0. That's a -4, sorry. I said it and I didn't write it. -4 plus 0. So now if we wanted, we could think about what we would do to our bottom row and write in our bottom row. So for the bottom row, I would probably do 2 times the top row plus the bottom row. Is that okay? So I'll write that down. 2 times the top row plus the bottom row. And we're putting that on the bottom. So 2 times the top row plus the bottom row is 0. 2 times the top row here is -10. Plus 4, -6. 14 plus 1. 3. 0. 2. Are we agreeing? Okay. Oh, I like that. It's 2 plus 0, isn't it? 2 times 1 plus 0. I think. Yeah, actually, that set us up in a great position. That 7 and that -6 in the next column look pretty good to me. So if we can just add the bottom row to the middle row and put it in the middle. So row 3 plus row 2, and we're going to put it in the second row. So the first row is not changing, and the bottom row is not changing. The middle row is changing. So if we add these two together, we get a 0. Add these two together, we get a 1. -3. It's kind of nice when you're just adding them. -1, 1, and -2. Okay. What do we want to do next? Should we get the 0 underneath the 1? We want a 0 here. We also want a 0 here. So if you want, we could get those 2 zeros in one step. Not doing it all at once, but doing it row by row like we did here. You want to do that? I like that those are both negative because we aren't going to have to times by a negative. So that makes it a little easier. So we're now going to leave row 2 the same. Row 2 is not changing. So I'm going to write my row 2 in. Let's change the row above it first, and then we'll change the row below it. So if we want to change the row above it, we're going to do 5 times row 2 plus row 1. 5 row 2 plus row 1, and that's going to row 1. 5 times 0 plus 1 is 1. 5 times 1 plus -5 is 0. Let's see, that's a -15 plus 7, so -8. This will be a -5 plus 1, -4. But I'm only timesing by positive 5. I'm not timesing by negative 5. Okay, and then 5 times 1 plus 0 gives us 5. And then 5 times negative 2 is negative 10 plus 1 is negative 9. Is it negative 9 or positive 9? Negative 9? Okay. So that changed our top row. And now on that same matrix, we can do an operation to change the bottom row. So in the bottom, we have a negative 6, so we're going to times by 6 now. 6 times row 2 plus row 3, that's going in row 3. So 0 in the first spot, 0 in the second spot, negative 18 plus 15, negative 3. We're timesing 6 by the second row and adding it to the third row. So 6 times this, 6 times negative 6 plus 3 is negative 3 again. 6 times negative 3 is negative 18 plus 15. I think these are okay. Who doesn't like the negative 3s? They're okay? All right. 6 times 1 plus 0 gives us 6. 6 times negative 2 is 12. Plus 2, negative 12 plus 2 is negative 10. Okay. All right. Oh, this is not bad. Okay, so I am not going to divide out the 3. If we will in a minute, but not yet. That's going to give us a fraction over here. I just want to avoid the fraction. But if we change the signs here and we add it up, we can get a 0 right here. So our goal right now is to get zeros here and here. This one's going to be easy to get. This one is not going to be the best, but we can do it. We'll probably get a 1 here first, and then we will have to deal with fractions on that very last operation. But we did a great job of avoiding fractions so far. So we're going to change our signs here. I'm just going to change them positive, positive, negative, positive. Okay, so we're going to add the bottom 2 rows and put it in row 2. So this is row 3 plus row 2, and we're putting it in row 2. That means row 1 is not changing and row 3 is not changing. Oh, whoops. I just wrote row 2 in there. That's the one I want to change. 0, 0, 3, 3, negative 6, 10. Is that okay? Okay, so if we add those 2 together, we get 0. We get 1. We get 0. I'm getting 2, negative 5, and 8. Okay. All right, so now we are going to have to go into fraction world. We do want to just get a 1 here. I would keep the 3 if it would help me with the 8, but it won't. So divide this one by 3. We're almost done. Only one more matrix after this. I mean, one more matrix to write out on this problem. We're dividing row 3 by 3. And the first 3 are great, and then we have 10/3. Don't go into decimals, keep them as fractions. You can reduce the fractions if they reduce, but don't go into decimals. Okay, so we have only one element that we need to finish fixing, and that is we need a 0 here. And then we will have our identity matrix and we'll have our answer. So we're going to have to do 8 times row 3 and add it to this row 1 at the top. So our operation is 8 times row 3 plus row 1, and that's going to go in the row 1 position. And then we'll have our answer. So the top row is the one that's changing. The bottom row is not changing. And the middle row is not changing. 1, negative 2, and 10/3. Okay, so most of them are going to be okay. The last one's the only one that you have to be really careful with. I would just use your calculator. Do 8 times 10/3 plus negative 9 in your calculator. So 8 times this plus this is just 1. 8 times 0 plus 0 is just 0. 8 times 1 plus negative 8 is 0. 8 times 1 minus 4 is 4. 8 times negative 2 is negative 16, plus 5 is negative 11. 8 times 10/3 plus negative 9. Say again. I'm only timesing by positive 8 though. So it's a negative 16 plus 5. I think it's negative 11. This one has a negative 8, so I want a positive 8. Okay, 53/3. Okay, so your answer would be this. So you start by augmenting it on the left. You migrate it to the right. Once you get it to the right, you have your answer. Super fun, huh? Okay, no, we're not going to do the other one. Sorry, you can practice that on your topic. But I do want to talk about the other one for a second. And I want to check our answer and make sure it was right. It's right. 4, 2, 1, negative 11, 5. And I actually think the way we did it was easier than the way I did it. You just never know what path you're going to take. Okay, so not every matrix has an inverse. So when you're doing this topic, you will have to choose A inverse exists, and you'll have to find it, or you will choose A inverse does not exist. Yes, but usually when there's no answer, you stop like right here, you realize. So I just want to show you what it looks like when you're done and there's no answer, okay? So if I was doing this problem, in fact, it only took me 3 steps to realize there was no answer, okay? And I'm not even going to do the 3 steps. You would do the same thing we did. You would augment it. You would start your operations. You would be going along, and you would reach a point where you have something like this. Yeah, we can't get a diagonal. We ended up with a situation where we ended up with a row of zeros on the left. So if you get a bunch of zeros here, there's no need to continue. You're never going to get a 1 back here, because if you try to get a 1 here, maybe you add down, you end up with not a 0 here. So if you get a bunch of zeros, 0, 0, 0, you're done. It's called singular. This is a singular matrix. It does not exist. Okay. All right, so the last 2 topics are on something called finding the determinant of a matrix. The determinant of a matrix is very, 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 very handy. It's used a lot for a lot of different things. But like none of those things are in the scope of this class. They just want you to know how to find a determinant in case you do the next class so that you'll be able to use it for other things. Determinants are, they use like absolute value bars. They don't have to mean absolute value. In matrix world, they mean determinant, but it's the same bars, right? So if you want to find the determinant of a matrix, it is this diagonal subtract this diagonal. So this one has a determinant of 4. Yeah, 3 times 0 minus 4 times -1. It's always the forward diagonals, or the forward diagonal minus the backward diagonal. Yeah, it's not algebra, it's just a quick calculation. So a 2 by 2 determinant is super easy. 3 by 3s aren't bad. Oh, it was on there. AD minus BC. AD minus BC. So if I want the determinant here, it would be -42 minus 2, so -44. This one would be 6 minus -5, so 11. Yep, plus 5. You feel okay about 2 by 2 determinants? Okay, 3 by 3 determinants are different. This is the equation for it. Garbage, right? Okay, but I'm going to show you a way to do it that's, I think, not too bad, okay? It's crazy, right? Well, what it is, I'll show. What it is it's this number times by this determinant minus this number times by like this determinant. It's weird. It's crazy and it's really hard to do. But there's an easy way to do it. Okay. You know how like I was doing diagonal minus diagonal? Well, the problem is that leaves off a bunch of numbers, right? It's just not right. But if we do something fancy, we can do diagonals. What you have to do is, we have one column, 2 columns, 3 columns, start repeating it. 2, 1, -5, 4, -3, 5. You don't need to repeat that one. Just in order, start repeating the matrix. Repeat that column, repeat that column. Okay, now we can do diagonals. But there's a lot of diagonals. But it's still easier than figuring out what that's saying, okay? So our forward diagonals are, that one times this to give us 6. Okay, so we've got a +6. This one's still positive because we're still going forward. This one is 0. And still going forward, this one is 10. Is that okay? Now we're going to go backwards and we need to subtract. So our backwards diagonals are -4. Don't forget to subtract them. Put a big subtraction sign because you're going to subtract all of them. Or I don't know, do whatever you want. Just make sure you subtract all of the backwards ones. The first one was a -4. The next one is a 0. And the last one is a 30. Doesn't it have a 0 in the middle? We're timesing. Yeah, multiply the diagonals and then add them up. Just be careful. Any backwards one has to be subtracted. So either do a big grouping to remind you that you're subtracting all of those, or make sure you subtract each one individually, right? So this would be 16 minus 26, -10. You only do the ones that are a full diagonal. So like you're not going to do this. because it's not a full diagonal. Does that make sense? We're going to practice it again because it's a little weird. And I wanted to make sure we got the right answer because you never know. And maybe I lost that page. Guess we'll never know if we're right. All right, so you repeat 2 of the columns in the same order that they appear in the original matrix. You do your forward diagonals. And you subtract the backwards diagonals. Is that 120? We're timesing. We're timesing. You multiply the diagonals. Yeah, I did. I was thinking of the subtraction ahead. You decide which way you like to do it. I would either do it like this, where then you're thinking about distributing it, or think about that each time that you're subtracting. However, you can best not lose the negative. I don't want to do that in my head. What did we get? Let's make sure we all get the same. I got negative 83. Okay, I'm going to do it again. I probably have a sign error, honestly. Erase. Negative 2, 5, 1, 4, negative 1, 1. That's a 12, right? The next one over is an 8. The next one over is 45. Okay, now we have to go backwards. I don't know, I lost it. Okay, so backwards we have 120. We have negative 4. And we have negative 9. I swear that's what I had. Oh, I didn't type the 5 when I did the 45. I typed it, but it didn't take. Whoops. Negative 42. Okay, that's it. The inverse one is the tricky one. The other 2 determinant ones aren't bad. It does kind of summarize that here, but again, sometimes reading stuff like that is gross. Do you want to do another one, or you're good? Okay, you're good. All right, let me know if you need help on anything. These 2 topics, these 3 topics that we talked about today are not actually due this week. They are due next week. So if you want to work on your older stuff, that would be great too. Did you just say someone's being a sassy bat?
No, brat.
Oh, brat. I like bat better, actually. If you have a knowledge check, then you probably should do it. I can turn it off if you want, but it's probably better for your practice test 5 score if you do the knowledge check so that you can figure out which things you need to study. You know what I mean? No, not on a knowledge check. Oh, I found the answers, -10 and -42.
We got like 3 hours.
If you want me to skip your knowledge check, I will. Just tell me.